Now we're going to have a look at question 19. Question 19, this comes from the 2020 HSC Advanced Maths paper. So this is a trigonometric proof question. We have to prove a particular trigonometric equation, a particular identity. You have to show that one of the sides is equal to the other side. We're going to be using a very specific method in the case of these questions. So we have secant theta minus cosine theta is equal to sine theta times tan theta. Now this is going to be called the right hand side, RHS. This is going to be called the left hand side, LHS. The way that we're going to do this proof is we're going to pick one of the sides, work only on that side and turn it into the other side. This is a very specific type of proof. It's a very specific way of demonstrating that this is true. It's not the only way. There's quite a few other ways that involve manipulation of both sides of the identity. For example, reducing an identity down to 1 equals 1 or some trivial statement is often sufficient to demonstrate that it's true, at least for certain sets of numbers. For these questions, you really want to pick one side and you want to turn it into the other one. That's what the markers want. That's what the marker notes tend to want. That's how this is the main way that this tends to be done within the HSC Advanced Maths course. It's usually better to work on the quote-unquote more complicated side. So if there's one side that has multiple different terms in it or more stuff in it, it's usually going to be easier to reduce that down to the simpler side than it is to start with the simpler side. So for example, the right-hand side is a product of two functions. And in fact, tan is sine on cos. So the right-hand side is just sine squared on cosine. And there's not much you can do with that to break that up with any ease. You can, but it's a little bit more difficult. So we're going to work on the left-hand side. So our goal is to use trigonometric identities, substitutions, trigonometric algebra in order to turn the left-hand side into the right-hand side. So LHS is secant theta minus cosine theta. Good strategy for this. If you have secants, cosecants, or cotangents, sub them out for sines, cosines, and tans. Because the fewer trigonometric terms you have, the fewer sinusoids you have, the easier this is going to be. So secant we know is 1 on cosine. So this is 1 on cosine theta minus cosine theta. Now these can just be added together. We need to put the cosine theta is of course cosine theta over 1. We need to make the denominators the same, and then we're going to add them. Subtract them in this case, but compose them together. So multiply the numerator here by cosine theta, multiply the denominator here by cosine theta. This gives me 1 on cosine theta minus cosine squared theta on cosine theta. Now notice, same denominator. So now we can just add the numerators and leave the common denominator. 1 minus cosine squared theta divided by cosine theta. Now, this doesn't look very good, but this is very close to the answer that we actually want. The numerator, 1 minus cosine theta, whenever you see things like, the numerator, of course, is 1 minus cosine squared theta. Whenever you see cosine squareds or sine squareds, this immediately in your mind should remind you of the sine squared theta plus cosine squared theta equals 1 identity. It's really an identity because it's the case that it's always true that sine squared theta plus cosine squared theta is 1 for standard values of theta. So we have a cosine squared in the numerator. So we can get rid of that. We can substitute that out. So if we rearrange the identity we have here, minus sine squared from both sides, we'll get cosine squared theta is equal to 1 minus sine squared theta. So 1 minus sine squared theta is going to go where the cosine squared theta is. So this gives us 1 minus sine squared theta over cosine theta. So the 1's cancel, 1 minus 1, minus minus sine squared is just sine squared theta. So sine squared theta over cosine theta. Now this is the answer. It's not in the right form, but all of the trigonometric working is largely done. We just need to change this so that it looks like sine theta tan theta. So sine squared theta, well that's actually just sine theta times sine theta. So we have sine theta times sine theta on cosine theta. Sine theta on cosine theta is of course tan theta. So this is sine theta, tan theta. And this is of course the right hand side. So we started with the left hand side because it was two separate terms, and it's usually easier to start with the side that is more complicated, so to speak. Two individual terms on one side does make that, in a sense, a little bit more complicated. We then used our knowledge of trigonometry to swap out the secant for a 1 over cosine. We then used our knowledge of the sine squared plus cosine squared equals 1 identity to substitute out the cosine squared. This happened to reduce to exactly what we needed, which was sine squared theta on cosine theta. Now, sometimes when you see these questions, the markers at the start, or the people doing the questions, will take the right-hand side and they'll turn that into sine squared theta on cosine theta, and then they will regard the question as being finished at the point where they have sine squared theta on cosine squared theta. They probably don't do this. Turn the left-hand side exactly into the right-hand side that is shown in the question. Right? The HSC people just tend to be really fiddly about this. They really like it done in that way. There's a bunch of videos on YouTube of Eddie Wu talking about this, where he sort of, the crude logic is if you don't turn one side exactly into the other side, you haven't necessarily demonstrated a proof that they're equal, right? And that is a approximate philosophy that the HSC teachers and markers tend to have. It's not a perfect philosophy, but it is the philosophy they're going with, right? So they've said, this is how we're going to do these questions. Pick one side, turn it into the other. In terms of marking, to get 1 mark, you really have to have some attempt to do this question. The marker notes want you to have 1 minus cosine squared on cosine. So they want this. But if you don't get that, but you get something of a similar level of effort that doesn't quite get you an answer but gets you close to an answer, that's going to get you 1 mark. So sort of this bit here is our first mark. In order to get the second mark, you need to show that one of the sides is equal to the other side. So in this case, this was getting down to the fact that the left-hand side was equal to the right-hand side by showing that the left-hand side could be written as sine theta tan theta.